In this video, I will explain exercise 11E, question 25 and 26. I mean, some of you cannot get 25 boy, and quite a lot of you cannot get 26 boy correctly. I've marked down in the comment of your practice work if you check the Google Classroom. So box A contains 25. Box A contains two black, one red. Box B contains 3 blacks. First, we are drawing a ball from A and then put into B, our first step. In this step, getting a black, or I just use small b and small r for black and red, is 2/3 and 1/3. And then second part is B, put it back to A. I need to draw a ball from B to A. If I put a black to the box B, actually there will be 4 black here. So we don't have the red. You can mark down the probability is actually 1 here. If I put a red ball from A to B, then now I have 4 balls in total. 3 of them is black, and then 1 of them is red. Now, which is the case we want in the question? The probability that red ball in A. Let's see. If I didn't move the red ball, that means this case, the red ball will be in A. If I move to B and then move it back, this case is also in A. So the final answer is 2/3 times 1 plus 1/3 times 1/4. The answer you get is 3/4. Part B. Part B, the situation is repeated. So we put A to B, B to A, and then do it one more time. Because we already find out the red ball remain in A, that means if back to this situation, the probability is 3/4. So when I draw the tree diagram, I don't want to redraw this part to here or add so many things here. I just mark down up to here where is the red ball first. The red ball in A or the red ball in B. The red ball in A, that means the situation is the same as this one. So we already have the probability. 3/4 is this. 1/4 is this. If red ball in B, let's see what is the situation. It is the box A contain what and box B contain what. The red is here. Since we didn't change the total number of balls, 2 black, 1 red here. While A have 3 balls, they are all black. So next, now I want to do the process for the second time. This one is the same as before. So we can apply the 3/4, 1/4 again. After doing the second process, in the end, the red ball in A and red ball in B is same as 3/4, 1/4 again. But now this one we need to think about the process. A put to B, B put to B again. If A put to here, if I take a ball from A put to B, then it must be black ball move to here. So it will become 3 black, 1 red in my first step. Next, if I put it back, now we have 3 black, 1 red. If I pick a black here, 3/4, then the red ball will be in B. If I pick a red ball, because this step I'm putting back to A, then red ball in A. After making these 3 diagrams, you should be able to get the answer. 3/4 times 1/4 plus 1/4 times 3/4 for the red ball in B. Final answer 3/8. Question 26. We are given this, and then the situation is if a boy taller than 1.75, you will see selecting 2 boys. So first we count it. There are 5 each. And then not just select it, we need to check whether he plays basketball. The probability he plays basketball, if they are from here, is 5/6. If they are from here, 1/3. 2 boys are chosen. So this question is testing you how you can list out the case. And then after chosen, if we want to check some events, it's a times. Select is first step, second step is play or not, is the times. 2 boys taller than 1.75, none of them play basketball. Here, if you think about it carefully, we only have 1 case. We choose 1 here, and then second one we also choose here. So the first boy is, we have 5 choice out of 10. The second boy we have 4 choice out of 9, because both of them chosen from here. And then each of them multiply probability. He does not play basketball. Does not play basketball. The probability, both of them are 1 minus 5/6. Then we get the answer 1/162. Part 2, A2. 2 boys do not play basketball. Be careful. Both of them do not play basketball, but they can be both here not playing basketball, or both here not playing basketball, or first here not playing, second here not playing, and first here not playing, second here not playing. The last 2 cases is the same value, so you can times 2. So I list out the case again. The first, second, first greater than 0.75, both greater than 0.75, but both don't play. I use this one to mean not playing basketball. One of them, first is this, second is this, both don't play. Because not playing basketball, it depends on the height. So we need to break into these cases. And then this case need to times 2 because I can switch their order. Lastly, both are shorter than or equal to. And then in the end, just plug in the number carefully. The first case is 1 greater than 1 point. Choosing them is this. And then at least now you have learned NCR. Actually, you can use NCR to combine these two probabilities. Make a 5C2 divide 10C2 is also okay. Then you don't have these two cases. And then now the not playing basketball is 1 minus, actually the first case is the part A1. And then second case and third case they're the same. So later I will put a times 2 here. And then first is 5 over 10. Another one we still have 5. For greater than, if I think about the first one is greater than 1.75, then not playing is this. Another one not playing is 1 minus 1 for 3. Last case, getting two people like that is this probability. Each of them I don't want them to play basketball. Is multiply 1 minus 1 over 3. In the end, add all the cases. You should get the answer. The answer is 1 over 6. The last part, Natalie claims that the probability of choosing two boys who do not play basketball is greater than choosing two boys who play basketball. Who do not play is 1 over 6. Two boys both playing basketball. Same idea, just like our A2. Be careful, they are not complement event, not a 1 minus. Both don't play and both play. It's not a 1 minus. We still have other cases. One play, one not playing, so on. So what we can do is, again, think about the cases. The cases are both taller than, but they play. Two second and third cases, taller than, shorter than, or equal to. Both playing. Lastly, both are shorter than. And then both playing. This is the same pattern. So I just quickly write down 5 over 10 times 4 over 9 is the choosing, selecting. And then for greater than 1.75, playing the probability 5 over 6. And then the last case first is same pattern, 5 over 10, 4 over 9, playing the probability. All of them are 1 over 3. The first one is taller than, second one is shorter than, or the reverse. It's like this, both are 5 over. One of them times are 5 over 6, one of them times are 1 over 3. Since we are using times, we imagine we have first, second. This case make a times 2. A lot of you miss this one. Cannot get this part correct. Usually it's missing the times 2. Using times, our thinking is first, second. First people, something happened. Second people, something happened. In the end, and do a plus, then you should get the answer. This value will be 1 over 3 if you press it carefully. So 1 over 3 is bigger than 1 over 6. Answer in A2. So that is why no. A lot of you cannot get this one correctly, but you still get a value greater than 1 over 6. When checking the answer, you don't figure out you are getting it wrong.